In order to understand the constant E, we're going to take a look at an interesting compound interest problem. The way that compounded interest works in a bank is that you put money in and you get some rate of return. And since your rate of return is generating more money in your bank, you then have more money to generate more money with. The interest compounds. And so in this problem, we have some frequency of how often we compound, the number of times that the interest is calculated in a year. We have our formula, and then we have the resulting dollar value, assuming a 100% interest on a $1 investment. Let's take a look and see what happens. Say we have an annual compounding, so n equals 1, we compound once a year. We use the formula 1 plus 1 over 1 to the first power, and that's obviously just 2. But now if we have semi-annual, n equals 2, we have 1 plus 1 over 2, according to our formula, all to the second power, so 1.5 squared is 2.25. We continue to do this more frequently. Let's compound quarterly. And now we have 1 and 1/4, all to the fourth power, which is 2.44 approximately. And if you continue on this trend of increasing n, the number of times that interest is calculated per year, you're going to continue to go up in your dollar value, but only a small and smaller amount each time you increase that n size. And as we go higher and higher, you'll realize that we're leveling off at a single constant value, around 2.718 something. Well, it turns out that that number is actually called the natural number E, and its approximate value is 2.718, and it's one of those irrational constants similar to pi that goes on forever, but it pops up all over mathematics. This example here with compound interest is just one concrete place where using this formula, as you get a larger and larger n, you can get a more accurate value of E. However, it shows up everywhere in calculus, for example, where it turns out that the slope of the exponential function with this base can be defined by the function itself, which turns out to be a very useful property, amongst many others. So E is a constant. We're going to call it the natural number, and its approximate value, 2.718, will be the base for many an exponential function in this unit.